Hello guys, welcome to my YouTube channel. Today we are here to solve Leetcode problem of the day, and today is 3rd September 2025, and the problem is partition array according to the given pivot. So from the title it says that you will have an array and you have to make the partition of array according to the given pivots. So from the pivots what we say that what we what we think is that it's something asking related to the quicksort, because in the quicksort we use the pivot element. We assign a pivot element, and according to the pivot element we switch, we swap the elements, and we sort the given array. So the problem is asking something like that. Maybe we can assume that it is asking something like that, and then in the constraints the size of given array is 10 raised to the power 5, and the element values can be differ from minus 10 raised to the power 6 to positive 10 raised to the power 6. And here it is given that there will always be a pivot element in the given nums. So from these constraints we can say that we have to implement an algorithm so that we can come up with a solution like n log n or maybe log n. We cannot do any square or something larger time complexity solution. So let's try to read the problem statement now. You are given a zero index integer array nums and an integer pivot, as it is given that there will be an array and there will be a pivot element. So these are the rules such that the following conditions should be satisfied. You have to rearrange the nums such that the following conditions are satisfied. In the first point, every element less than pivot appear before every element greater than pivot. It means that each element which are less than the pivot should appear before the pivot, and every element that is greater than pivot should be appear next to the pivot element. And in this case, if the pivots are equal to the pivot's element, if the element is equal to the pivot element, then it should be in between these two. And so from these 2 points, it is something very similar to the quicksort. What we do is that we shift every smaller element than the pivot in the left hand side, and we switch every greater element to the right hand side. But there is the catch in this problem. There is slightly different, that the relative order of the element then less than the pivot and the element greater than pivot should be maintained. So this is the extra rule that your code should reflect, that relative order should be maintained during swapping, during rearrangement of the given array. So this is given in the text form, that more formally consider that if pi pj, where pi is the new position of the ith element and pj is the new position of the jth element. So if the I is less than j before, then the both elements are smaller than pivot, then pi should be less than pj. And in the similar order, if the element are greater than pi and pj is greater than, so if I is less than j, then pi should be less than pj. So you have to, and after the rearrangement you have to return out the final array. So you can see in the example 1 that here it is given an array and here it is given a pivot element, then here it is the output. So you can see that if you can see that 10 as the pivot elements and 9 should appear, then 5 and then 3. So 9 5 3 is here, and 10, and these two 10 are here, and then we will check what is the greater element. So here it is 12 came first, so that's why 12 is here, and here it is the 14, so there will be the 14 here. So let me show you quickly that how why we cannot apply the quick sort exactly, because even though it will swap the elements that is less than element in the left hand side and what is the element that is greater than the pivot in the right hand side, but it could not be able to maintain the order. That is the third requirement of this problem. So that's why we cannot be able to use the technique of quicksort algorithm. So let me show you quickly that how why we cannot be able to. So let's say that it is 9, so we will modify this one. So okay, then here it is pointer 1, so here it will be the left pointer. Let's say it is the left pointer, and then let's say that it is right pointer. So what we will do, we will see that if the element is less than pivot, we will move the left pointer, and if the pivot is greater than or equal to, no, if less than or equal to, we will swipe, we will move the left pointer, and if it is greater than pivot element, we will stop and we will move this pointer and we will swipe it. So this is the less than, this element is less than pivot, because in the example one the pivot is 10. So what we will do, we will move it, and again we have to, so this is greater than the pivot, so we will stop it. So I have told you that we will check the greater here from the right hand side, so 10 is less than, so I will swipe it. So that's why it here it will be the 10 and here it will be the 12. Then again we will move the left pointer because it is less than, so it will be there, and we will move 10 because it is less than, so it will be there. So it will be the 14 here, and the left pointer will point to here. It is greater than, so it will move to the next one. So it is a 14, and here is the 3 because it is less than, we will swipe it, so it will become 3 and it will become, what was there, it was 14, so it will be the 14. So you can say that we can be able to you know do the operation partially, because all the greater element is here and all the less than or equal element are here. In the resultant we can apply the same thing again in the subpart. So we will make it remain, and from here we again apply the same rule, that left pointer will point to the left pointer will point to here, and the right pointer will point to here. So left pointer is, and in now in this case, if the less than element, then we will move the left pointer, and if it is greater or equal to, we will stop the left pointer, and in the similar case, if the element is less than, we will stop it, and if it is greater, we will continue reducing the value of r. So here it is less than pivot, so we will move, so it is greater than or equal to, so we will stop it. It is less, so we will, what we will do, we will swipe it, it will become 3 and it will become 10. Now we will again move this pointer, so this pointer will move to, because to the next index, and here it is the 5, it is less than, so it will become here, and this pointer, as we have seen that here it was pointing earlier, because it is equal to the pivot, so we will reduce, and then these two pointer will collide at this index, and when we will, it will collide, we will end the loop. So from here you can see that even though here this is the pivot, You can say that pivot elements are in the middle and the smaller element are in the left and greater element are in the right hand side of the array. But what the problem is that we have maintained these two, but we could not be able to maintain the relative order during the rearrangement using the quick sort, because you can see that our output is, let me show you here, that our output should be like something 953, but our output is 935 and 10 10 and 12 14 and 12, but the output is 12 and 14. So from here what we can conclude that we cannot be able to do the operation accord, do the rearrangement what the problem is asking because of the third point constraint. So from here we cannot proceed with the technique of quicksort. So what we can do next? There is the two approach. In the first approach, you have to sort the array on the basis of n log n, because we are using the sorting. So the time complexity will be n log n. And in the second approach, what we can do, we can reduce this time complexity, because we cannot read. Let me clear one more thing, that can we use, can we solve without any extra spaces? Can we I mean that can we solve the problem using constant space order of 1? So the answer is no, because somehow because you have to maintain the order, we have to take the extra spaces. So in the first, as I have told you, that there is a two approach. One is we will do the sorting, and in the second approach we will do the iteration, but we will take the order of n as space complexity as well as the time complexity. Both will be of order of n. But in the sorting algorithm, in the first algorithm, it will be n log n is the time complexity and order of n will be the space time complexity. In the first approach, what I am trying to say, that I will store the index, and then I will sort it, and then I will sort the array, and then I will find out the what is the index of first group and what is the index of second group, and sorry, what is the index of this first group and third group, and on the basis of that I will sort this first group, and on the basis of index I will sort this group, and I will sort this thing. So firstly I will sort on the basis of values that are given, and then I will sort on the basis of index to each group, so that they can maintain the relative order that is given in the. So for the first approach, you just do not have to do much. You have to just store the indexing like this one, that it index 0 it is 9, and it index 1 it is 10. Here, let me show you that in the big. So if you will store that, when you are ready to go, it index as a 2, it index as a 5. Similarly you can make it, and you can sort them, and then you have to find out the what is the index, so that we can make the groups, group 1 and group 2 and then group 2. So from index 0 to, let's say, 0 1 2, from 0 to 3 we will sort on the basis of index, and then from 3 to 4 we will sort these two, and from in this index we will sort this third group. So it will give you the correct ordering, so we can just copy the values in the nums and we will return it. So this will be our first approach. But in the second approach, because we are using the sorting, so sorting takes n log n time complexity, so we can reduce the order of n. How we can make the order of n? Because what we are doing here, that we are making the groups, because in the first three index there will always be the element that is less than pivot, and in the next two index there will be the element which will be having equal to value equal to the pivot, and then next, and what will be remaining will be appear in the next group. So what we can do is that, okay, we can, if we are able to find out the first index, this one, and this index, and as well as this index, so what we will do that, okay, there are the three indexes, there is the three variable which will indicate to this index and this index and this index. So what we will do that, whenever we will hit a value that is less than pivot, we will put it here on this index, and then we will move the that index and that variable to the next. So if there is the element that is greater than equal to the pivot, we will move, we will put that it the element on that index, and we will move the second variable to the this one, and then there will be the third pointer, and whenever you will hit an element that is greater than pivot element, then we will put it here, and then we will move the pointer to the next index, to point to the next index. So in this case we are not using the sorting, we are just using these three variables, so that we can do what was the expectation of this problem. So I think it is clear now. Do I need to say something more? Yeah, you cannot modify the current one, you have to take the extra spaces so that you can maintain it. So we will iterate this index, we will iterate the given, we will iterate the given array, and we will take an extra array to assign the value, so that we can get the correct order what was the expectation of this problem. So let me code it now. So, and make a variable, and this will be the result, let's say answer. So I will return this one, so this will be the answer. Okay, index 1 equal to 0, and then index 2 equal to 0, equal to, okay. num so if num is less than pivot, what we will do that, we will index 1, and if num is equal to pivot index 2 plus plus. So in this way, and then we can see this was the example, then these first three elements will appear here, and these two starting index will be from here. So it will go 0 1 2. So the first one is from start from 0, the second one will start from here, and the third one will start from here. So what we can conclude that index 3 will start from 0 1 2, 1 2 3 will start from 3. So 3 and then 4 and 5. 1. So if I will add index 1 plus index 2, so it will become 3 and 2, it will become 5. So 0, 1, 2, 3, 4, 5. So you can say that it will start from here. Starting index of the right element that will be on the right hand side of the pivots, and for the index 2 will be equal to index 1, and index 1 will start from 0. Okay, then again, then and nums of I is less than. So what we will do, sorry, it will answer of index 1 plus plus. I think it is okay. Yeah, else if nums I equal to pivot answer index 2 plus plus equal nums of I, nums of I, okay. And then in the third case, what we will do is that answer of index 3 plus plus equal nums of index 3 nums of I, sorry, and then at the end we will return the answer. I think it is done now. Let me run it. So I forgot to add the semicolon. So you can see that these two test cases that are given here have been passed, have been accepted as well. So the output is this one, and this was the expectation. So let me submit it now. So you can see that our code have been submitted and have been accepted as well. And what is the time complexity? As I have mentioned, that time complexity is order of n, and the space as well as space is also order of n. So let me see here. So you can see the time complexity is order. So let me show you the space complexity is also the order of n. So this is all about the problem. If you have any query or suggestion, you can ping me below in the comment box. I will reply as soon as I will get the time. So all right. So please, if you feel that my videos is helpful for you to prepare for the DSA as well as the CT, you can like, subscribe, and follow my channel. And please also make sure to share with your friends that are interested in coding. Thank you and have a nice day.